All right, guys. Continuing on with section 9.3. So we were talking about evaluating logarithms. We've converted them back and forth. We talked about their purpose and why they must exist. And actually, if you're going into applied sciences like chemistry, biologies, engineering, material sciences, thermodynamics, logarithms are a huge player in all of those fields. So they are important, but most importantly, I think it's important to understand how to approximate them, because they all don't work out as pretty. Okay, so if I were to give you this guy, log base 3 of say 81, you'd already know that the answer, and if you had to guess one, well, let's see here. You already know this is and we're at the point now where we're going to be cranking this out in our head. Okay, so put the time in it. Don't be watching all the videos at once. Space it out. Do some homework. Make sure you have the right understanding, and then go to the next video. Okay, do it in the right order. You'll get more out of it. Okay, so if you don't see it yet, right, then you're saying 3 to what same box is that equals 81, and you start to multiply things together, right? So you start multiplying it. If it's a 2, that'll be 9. If it's 3, it's 27. If it's a 4, yep, bingo, bongo. Then it has to be 81. And how do you do? Check it out. 81. 3 times 3 times 3 times 3 is 9 times 9, which is 81. So done, right? But what if this was log base 3 of, say, 10 then, right? Then what do we do? What do we do? What do we do? What do we do? Right? Well, the way you think about this is this problem was analogous to like saying what's square root of 16. Obviously, that's 4. That goes, right? Well, this one will be analogous to saying like square root of 3, right? Because what is square root of 3? I don't know. Square root of 3 is square root of 3. There is no other representation of it, right? Like that is how we'd write it. Now, what we could do and what we need to talk about is how we approximate them, because we still need to know where they are on the number line. So what square root of 3 is, we would say is that, oh, square root of 4, that's 2 about. Square root of 1, that's 1 about. So that means square root of 3 has to be 1 point something, probably closer to 4 than to 1, right? We'd do something like that, right? So we'd say it's 1 point something, and we can kind of estimate it that way, right? We could do the same thing with logs, okay? And that's kind of the goal, but it all goes back to converting it to thinking about it, right? So immediately we do this, and this is on the way of actually doing it. So let's pretend you had no intuition about it. It all starts with you converting it to even starting to think about it. And if it works, then it's a nice, cute number or a cute fraction, then it worked out perfectly. But if it didn't, then you're going to have to approximate it at least to know what it should be, right? So you convert this. This is 3 to what exponent equals 10. All right, so you start thinking to yourself, well, 3 to the first power gives me 3. That's too small, said the 3 little bears. Okay, that's too small. So let's go higher. Well, 3 to the it's taking too long to clear. To the second power. Well, that is equal to 9. Oh my goodness, look, that's still too small. So maybe I need to get closer to it. So that's still underneath it. You everybody see what had just happened there? So that's 9. So now maybe we need to go one higher. So 3 to the third power, well, that's 27. Oh, look. So now I want you guys to think about this. Since the answer's in that box, since I know the closest number underneath it and the closest number over it, what does this have to be? Okay, well, clearly it has to be in between which two numbers? 2 and 3. So that's good enough to say log base 3 of 10 is approximately 2 point something. Okay, now you can even make arguments that it's closer to 2 than it is to 3, because 2 is only one space in between there and there's 17 there. And that's a very good argument to have, right? But for our purpose of approximating and knowing it's in between 2 and 3 is what we really need, okay? Now, this is bad math. You don't never say 2 point something, okay? Call it 2.5 before you call it 2 point something, but I want you just to know that we just need to know which two whole numbers it's in between, okay? So let's try to grind out a couple more. So if we could do that, we're ready to rock and roll. No, we use the same method of comparison that we did before, okay? Find the guy below it, above it, and then we can figure out which two whole numbers it's in between if it's not perfect. Okay, so here we go. Approximate. Or better yet, here we go. Let's do this. Here we go. Place the following in order from least to greatest. Okay, I feel like it's always good just to jump right into things. Okay, and the first one is log base 3 of 10. The second one is log base 2 of 20. The third one is log base 5 of 20. And then the fourth one is log base 5 of 4. Okay, so let's take a second and let's grind through it, okay? Now, again, what are we going to do? We're just going to approximate each one and hopefully arrive at a logical conclusion, okay? Because we need to put these in order from least to greatest, all right? So this first one we did with the last problem, okay, which is actually where I got it from. Our justification was that we sandwiched it in between 2 and 3, and that's why this thing is 2 point something. Okay, so in my mind, I'm thinking it's 2 point something. All right, let's do the same thing here, okay? So I'm going to show the work right underneath it, and I'm going to have you guys start grinding out the numbers in your head. So 2 to what exponent is 20? Okay, because that's what we're going to do, right? When we convert it back over into exponential form. So 2 to what exponent is 20? Well, if it's 4, and you start thinking to yourself, okay? This is you thinking. This is not you writing on your paper this. If that's 4, then that would give me a 16. Well, if that's 5, it would give me a 32. All right, it's got to be in between 4 and 5, so the answer has to be 4 point something. Okay, but the spot in red you can do in your head. You don't have to write that down. Okay, if anything, if you write it like this, it's bad math. Write it on top and bottom of each other if you'd like, but don't write it like the way I just did. Okay, format your papers, guys, clean and attractive. And no one looks attractive right now because I have multiple colors. It's not that attractive when it's all the same color. Okay, so 5 to what power equals 20? All right, if it was 1, it would be 5. If it was 2, it would be 25. Right? So 1 was underneath it, which was 5, right? If we had the exponent as 1, it would be 5, right? And then the second one is 25. So I know this thing has to be 1 point something. And again, here's my justification. 5 to the first power is 5. 5 to the second power is 25. This is in between, so this has to be 1 point something. Easy peasy. All right, same thing here. 5 to what power is 4? Well, it can't be shoot. Let's see here. 5 to the first power is 5, right? And 5 to the 0 power is 1, right? So therefore, this exponent has to be point something. So note, I don't know because that's in between 0 and 1. Right? So now, I don't know which one, what the actual numbers are, but I can still put them in order. Why? Because I know point something is the smallest. So log base 5 of 4 is the smallest. The next guy would be 1 point something, which is log base 5 of 20. The next guy would be log base 3 of 10. And then last but not least, it will be log base 2 of 20. Okay? So long story short, we can approximate logarithms, and that's probably more important than actually solving them. Because how you think about solving them, anybody can do them, but approximating them, that takes a different kind of intelligence. Okay, so that's all I got for you guys. All right, so approximating logarithms. All right, putting them in order from least to greatest is just another good way of knowing how to approximate them. All right, so next video we'll start talking about some of the great log properties. I've been saying that every video, but I always seem to have one other thing I need to talk about. All right, so that's a section. Hopefully the close of section 9.3. We'll start 9.4 in the next video. All right, guys. Adios, and I'll see you on the next video.